All right, welcome everyone. My name is Sam Avery. Today I'll be giving a talk about various engineering projects I've done throughout my undergraduate career here. And it's titled Igniting a Passion for Engineering. So, to begin, I pose a question to you. Why should you be passionate about engineering? Or really, why should you be passionate about any subject or whatever it is that you want to pursue? And my basic answer to this question is, if you're passionate about a subject, if you really care about it, then you're intrinsically motivated to work at it and to actually get things done and to see good results. So things like external motivators like money or say recognition no longer matter to you, and instead you love what you're doing and you end up working harder and you also get better results. So this has kind of been my backbone, I guess. I love what I do in engineering, and I use this passion to drive me forward and to help me succeed in classes and engineering projects and etc. So just a brief overview of my seminar. I'll talk about multi-rotor helicopters and my work on a water landing helicopter. This was a waterproof helicopter, in quotes, waterproof, that was supposed to be able to land on the ocean and take off in the ocean and things like that. Some success there, so I'll talk about that. And then I moved on to do vibration damping research with the Cal 2 Summer Scholars Program, and I'll talk about the tricopter that I built and also show some cool videos of flying the tricopter around campus and things like that. And so I'll also talk about leading the UCSD Microgravity Team and basically our combustion or biofuel combustion research, and also kind of what it was like in microgravity and how it was leading this team. Then I'll talk about the TEDxUCSD undergraduate organized event. And lastly, I'll give some tips, some practical tips that I have to be successful, I guess, in life in general. Okay, so why multi-rotor helicopters? For me, multi-rotor helicopters, they allow for more stable images. So when you attach a camera to a multi-rotor remote control helicopter, you can get a stable image level to the ground, and more importantly, you can get it for way less cost than you would on a normal helicopter. On a standard helicopter, it might cost tens of thousands of dollars, whereas you can make your own multi-rotor remote control helicopter for under $1,000, and then stick a camera on it, fly it around, and get really good aerial photography of, say, real estate, of really whatever you want. In my case, I just flew toward Geisel and things like that and got really cool images of that. And then the most important thing is it's incredibly fun to fly, which is that's most of the reason why I decided to build a lot of these multi-rotor helicopters and test them and fly them. So, to start off, my first big engineering project, or one of the first big engineering projects I tackled, was to build this waterproof copter. As you can see here, I've been saying multiple rotors the whole time. This is called a quadcopter. As you can see, there are 4 individual rotors on the copter. And like I said, this improves stability, and so when you attach a camera to this, it improves the stability of the camera and allows you to get more stable footage relative to the ground, as opposed to just having a single rotor sticking out of the middle and flying around. And so I made this project with a small team of engineers with UCSD Engineers for Exploration. It's in collaboration with National Geographic and also under Dr. Albert Lin, who I'll talk about later. So this project was kind of just a self-funded idea that we took, and because we cared about it, because we were passionate about seeing a waterproof copter come to fruition, we worked at it and fully developed this. So to keep our electronics safe, we used this waterproof enclosure you can see in the middle. And then to be able to land on the water, we actually use pool noodles for flotation. So all these things on the sides are all pool noodles. And we were able to fully design and fabricate this copter. So I'll now show our first test. We took the copter over to the Canyon View pool on campus and asked the lifeguard if we could maybe just float around in the pool for a little while. lifeguard said sure, so here's our test. And so you can see we actually dropped the copter down into the water, and yeah, it looked really good. It was very stable. We got excellent footage from the copter, and lifeguard kicks us out in a second here, but yeah, it was very impressive, and it did what we wanted it to do. And like I'll talk about later, I really feel that my interest and passion in seeing this copter come to life and seeing this waterproof copter actually work was really one of the bigger motivations to creating this and then having it actually be a successful copter. And so here's just another clip from the GoPro attached to the bottom of the copter. This is from a boat just off the coast of San Diego. And you can see this is pretty stable, good image, even though we just strapped a GoPro directly to the copter, so it worked out pretty well. And so I guess what I learned from this project isn't really anything too important, I suppose, because I realized that a waterproof copter is kind of pointless, to be honest. So even though it was something that I was really passionate and determined about, like the passion and determination were really only there to help me, say, get funding for the project and to allow me to be able to do this project. So I guess I would say that if you're passionate and determined about a project, you can get other people to believe in you about the project, and you can have something that you love come to fruition. And so even though it is kind of pointless to have a waterproof copter, when say you could have like just a boat and then film off the boat, or say you could have just a non-waterproof copter and fly over the ocean. It was something we were very interested in seeing happen, and we thought it was a cool idea, so we were able to get funding, we were able to pull through with the project. And so moving on from that, I ended up working on vibration damping research, and that's with the tricopter that I had been talking about before. So this was with the Calat II Summer Scholars Program on a research project that I was under Dr. Albert Lin on, and I was researching multi-rotor helicopter frame vibration damping for aerial photography and videography. And what that means is I was reducing the vibrations in the motors in the frame such that when I attached a camera to it, it would get stable video, and then I could fly around and get really smooth video of whatever I wanted to film. So in my design of a tricopter, I started pretty low. As you can see, I started with a fancy Gladware container for the housing of the electronics, and then I also used rubber bands to hold all of my propellers in place. And this was back in freshman year, so I was kind of just getting started, kind of getting my feet wet in the engineering world, and I just decided to go for this. Since then, I've upped the ante on my copter quite a bit, and I've decided to actually do some design work. For instance, I started creating SolidWorks models of my parts before I tried building them, so that I could actually have something to base the model on and then something to base my fabrication on. So just to kind of give an idea of what goes into designing a tricopter. As you can see, there are 3 separate arms, and each arm has a rotating propeller, or a rotor, and these rotors all move in the same direction. This means that the copter will automatically spin to conserve angular momentum. Just the copter will try to rotate itself. So what you use is a motor attached to one of the arms, and this rotates one of the rotors, and this prevents the copter from spinning and prevents the copter from doing what's called yaw. So yeah, you can see it just prevents the copter from spinning, and this is one of the key components to developing these tricopters. And so with all these design parameters in mind, I decided to create a much nicer version of my tricopter than the first one you saw with the Gladware container. And here was my first successful flight. Sorry for the ear-splitting screech of this tricopter. So right at this moment, I was about as excited as I could have been for finally having my tricopter work. And this tricopter was actually controlled by a Wii Motion Plus, you know, like the Wii controllers, the Wii Motion Plus board. I broke open one of the Wii Motion Pluses, took out the 3-axis gyroscope, and then attached it to a microcontroller. And that was my control system. That was the stabilization for this copter. Still is stabilization, actually. So apparently it works really well, even if you only spend $5 on your control system. So I moved on from that to actually do some passive damping and to get some vibration damping in place so that whenever I attached a camera, I could get smooth video. As you can see, here is a slightly nicer SolidWorks model with a little bit more detail. And so what I decided to do was to use passive damping through vibration damping sandwich mounts. So what these do is, as they're compressed, they reduce the vibrations that are occurring in the motor itself. And as you can see, as the motor spins, it creates lift. And this causes that entire section and panel to lift upward, which pulls up on that bottom panel and allows the sandwich mounts to compress. And that reduces the vibrations significantly in each individual motor, which means that the whole frame has reduced vibrations. And that was my general idea going through with this. Even though you can still see it's kind of a janky, crashed design. I think I must have crashed this a couple times just before taking this photo. But yeah, the engineering worked, and the vibration damping was successful in this prototype. And here is the complete tricopter, complete with LED lighting on the sides, and as you can see, right there is the attachment for the camera. That's where I would directly bolt like a Canon camera to. So, to show off some of my cooler footage, I have 4 different videos here, and to start with, I'll show the direct mount without damping of this Canon power shot that you see to the left. So this is no damping, there aren't the sandwich mounts yet. And as you can see, it's ridiculously vibration-y, and it's very difficult to tell what's going on. So from a research point of view, from a science point of view, we can't get good data, good visual data from this copter. And even if it's only a couple $100 copter, it's still not successful enough. It doesn't get enough smooth visual data. So then what I did is I made the copter that I was showing you before with the vibration damping pads. And using these vibration damping pads, the same setup, the same directly mounted camera, I get this video. And clearly it's significantly smoother, and it's much better for seeing what's going on, even though it's not perfect, but it is still much improved from the first video. And then I also wanted to get some genuine aerial photography and videography that, you know, I could show off to other people and just basically show off what my copter can do. So I decided to loosely mount a GoPro Hero 2 in this case, directly to my copter. And what this does is it essentially doesn't allow the vibrations from the frame to connect to the camera, because the camera is so loosely mounted that a lot of the vibrations are kind of lost in the process, I guess you could say. So this gave me my smoothest footage yet, by far. And I'll skip ahead so you can see some higher aerial shots of Geisel. And so any non-stabilized portions of this video are really just me kind of getting my flight legs together, my sea legs, I don't know. Just preparing to be able to fly this kind of crazy Wii Motion Plus controlled copter. And so, yeah, as you can see, it's smooth video, it looks good. And so at this point, I asked myself what's kind of the what's kind of the coolest video that I could try to do. And I decided to do a speed test with the GoPro directly mounted to the copter. And so here I just started back toward EBU2, and I'm just going straight toward Geisel. And I decided I might as well show this. Oh god. So yeah, it's not all fun and games. Well, that still is fun and games, but it's not always good stuff when you're testing things out and trying to do some real engineering. So the reason why I crashed there is that I couldn't actually see the copter anymore. I didn't factor that into the equation. I just let it go and then just hoped that I could be able to save it at the end of that flight. Okay, so basically what I was doing with this research is trying to explore the unknown. Like the idea behind National Geographic kind of, and the idea behind my advisor Albert Lin, is to get out, explore the unknown, satisfy your curiosity about the world. I feel like research really does allow you to do this. And in that sense, research means taking risks and accepting failure, like crashing my copter. Once you're able to do this, once you're able to take these risks and accept the failure of, say, research and engineering, whatever you're planning on doing, you can contribute something useful to the world. And I feel like that's a really important thing in research, is you contribute something to the world, some new knowledge, some understanding of the world that wasn't there before. And so that's kind of what I took out of this vibration damping research. That was one of the big lessons that I took out of it. And so now I'll talk about the UCSD Microgravity Team and my experience leading this team. And you can see we have our very own fancy logo that one of our friends produced for us. So just to give a little background into what this program is, what the Microgravity University program is, NASA's Microgravity University program reviews reduced gravity research proposals from teams around the nation. So basically, if you're accepted to NASA's Microgravity University program, you're given a chance to fly on the 0G plane, or like a modified Boeing 727. And on this plane, you get to run your experiment in the free fall and the free float environment that the plane is able to offer. And so just to briefly talk about how that's done, the plane enters parabolic maneuvers. It's called parabolic flight. So the plane flies up, and at the peak of its parabola, it basically keeps you in a trajectory where you're floating in the middle of the plane. Like say in a roller coaster, at the peak of the roller coaster, you end up kind of free falling. You end up floating for just say like less than a second. In this, we free float and follow the trajectory of the plane for around 18 seconds. So in that time, you get to free float and then operate your whole experiment and get some good data while on the plane. So we were one of 14 teams accepted nationwide to the program last year, and this year we've been accepted again for an experiment reflight. So we're moving forward with our biofuel combustion research. And so here's the whole team in front of the 0G plane. This is us in Houston, Johnson Space Center. And this was last year. This was this July, actually. And then here's the team again in front of our massive experiment apparatus. So now I'll go in to talk about a little bit about the details of what our research actually was. We worked on biofuel combustion, or specifically fiber-supported droplet combustion of biofuels. And kind of to explain this, I guess I'll just show it. So as you can see, here are two crossing wires. There's a droplet in the center, and there's a flame surrounding it. And this fuel droplet is butanol, or a biofuel constituent. So what we would do is we would place a droplet onto these crossing fibers and then ignite it and film the combustion, film the flame that surrounds the fuel droplet. So now I'll discuss how we did that. So of course we're combusting something on a plane, we're blowing something up. We basically had to design and fabricate a triple contained system. That means you need 3 separate levels of containment to hold this flame well in the microgravity environment. As you can see in this intricate CAD model, we have 3 separate boxes, so a box within a box within a box. And these 3 boxes each are completely airtight, hopefully, that's what we're hoping for. And also you can tell that we have 2 separate cameras. One of these cameras is filming the droplet diameter over time, and one of the cameras is filming the flame diameter over time. This allows us to determine how the fuel burns and gives us a burning rate for the fuel. So you can see in the bottom center that there are 2 kind of syringe systems, and I'll kind of zoom in on those to give a better idea of what's going on. So here are 2 additional CAD models, computer models of the 2 syringe ejection platforms, as we call them. So what we do is we move an entire platform with a syringe on it in toward those crossing wires, and then we use a motor to compress the syringe plunger, and the syringe plunger ejects a single droplet of fuel at a time. And so then we can go and ignite the fuel. So supposing we already have the fuel on the fibers, now we need to be able to ignite it, which is a significant challenge considering that we have 3 different boxes and we need it to be an automated ignition. So our first thought was to use what's known as nichrome wire. And nichrome wire is something you can find in, say, like a toaster. Basically, as you apply current to this wire, it heats up and can get white hot through if enough current is applied through the wire. And here is a clip of that happening. So we basically took the nichrome wire. Oh, you'll be able to see it in a second, hopefully, here. We basically took the nichrome wire and actually shorted a battery with the nichrome wire. And here you can see it ignites the fuel droplet at a very, very close distance from the droplet. And also, as you can tell, there's a teardrop shape to the flame. This occurs because in normal gravity, you have flows which cause the flame to move in a teardrop formation. It's called convective flows, which occur because there's less dense air below the fuel droplet and it causes it to rise. And through that rising, it creates this teardrop shape. And that's why we're doing a microgravity experiment. That's why we need reduced gravity. And so, moving on, this is the photo that I was showing before of our butanol droplet combustion. And what we actually ended up doing is using nichrome wire. And that's what the 2 crossing wires are. The 2 wires you see holding the fuel droplet are now nichrome, whereas before we were using nichrome externally to ignite it. So at this point, we decided to use nichrome where the droplet is attached to the wires. And then the way we ended up igniting it was using a spark. So we'd create a massive voltage difference and then basically send a spark directly through the droplet. And so here's a video of the microgravity combustion. So we've turned the nichrome on at this point, and then we send that arm to ignite the droplet using a spark. And you could see the flame kind of wavering and creating a teardrop at times. It's because we're entering and leaving the microgravity period. But I'll play that one more time. So there we've already put the droplet onto the crossing wires. And then we shoot around, I think it's around 12 kilovolts to get that spark. And yeah, so that's good data for us to use, and we can capture the diameter of the droplet with time, and we can capture the diameter of the flame with time. And so you can hear the plane in the background. You can kind of hear us yelling throughout this. Okay, so that's kind of the basic gist of what we were doing with our research. I feel like we were really successful. We did a good job, we got some good data, and we also had a good time while at Houston. So here's just kind of video of what it was like in microgravity, and also, yeah, just kind of the craziest parabola that we had, I guess. So that's me in the middle. That's my friend and co-teammate, Jack Goodwin, who's also here. And the lady with the crazy hair right now is actually the astronaut Katie Coleman. So you can see everything is just going insane in this one. And I just do this in for fun. So that was lunar gravity right there. They also do lunar and Martian gravity while you're up on while you're doing the parabolic flight. Okay, so
Do you do that
yeah.
several times per flight?
Sorry?
Several times per flight you do that then, or is it just like a one shot?
The lunar is once. We did 30 different parabolas of microgravity, one lunar and one Martian. So we had a couple of fun ones to go through. It was really cool. So now on a slightly more serious note, I'll talk about kind of what it was like leading the team, and I guess doubts that I had about leading the team. So when I started leading the team, I initially had a lot of doubts about myself and my ability to basically work things out and to be an effective leader. So I thought I'd probably be inexperienced. I haven't really done this before. I've never really led an engineering team. I didn't really know what I was getting into. And I feel like I'm kind of an introvert, so I kind of am not as good at communication, and I've been working at it, of course, but I don't know, it just kind of weighed on my mind that might be an issue. And I felt I was going to be too unorganized to really effectively lead this team. But at the same time, I also thought I might be too poor at delegating because I was just inexperienced and I didn't really know what I was doing. But besides all of these kind of issues that I went into leading the team with, I really felt that I had like this core passion and interest in actually working at this project, seeing this research become successful, and seeing my team be successful. And I feel like despite the doubts, despite the challenges and issues and whatever else I had, the core passion kind of just let me overcome the rest of those doubts and the rest of those issues. And so I wouldn't necessarily say any of the doubts were true at like all the time, but I guess basically the core passion allowed me to get through whatever challenges that I faced. And I feel like in the same way, when you face engineering challenges, when you face, say, design challenges in your classes, when you face funding challenges, when you need to obtain funding to make your team successful, or when you face challenges with customers trying to help your client be successful, trying to get a good product to your client, and also when you're facing manufacturing challenges and fabrication, if you are basically inspired about what you're doing, if you care about what you're doing, then you can overcome these challenges, and suddenly they aren't really as big of a threat to you. So in the same way, your inspiration lets you overcome whatever challenges you face. And this is something that I personally believe, and I feel like it has helped me to move through whatever challenges I have through courses, through finals, through working, through just in general a lot of things in life. So now I'll talk about something that's inspired me to be a better person, to work harder, to be a better student in general as well. So I participated in the TEDxUCSD event. This is a subset of the major TED Talks you've likely heard of and seen some of and things like that. We decided to create our own independently organized event at UCSD as an undergraduate team. So just to give a brief overview in case you haven't heard of TED or TEDxUCSD, TED is kind of where the world's leading thinkers and doers are asked to give the talk of their lives in 18 minutes. So what that means is a person goes on stage, tells you all sorts of crazy stuff about their research and experiences in life and whatever they have that will inspire you. And then you listen to it and hopefully you're inspired. And so we decided to make our own TEDx event at UCSD, an inaugural TEDxUCSD event. And so we were a self-organized version of the major TED events, completely directed by undergraduates, and actually directed by Jack Goodwin, who was also on the team with me. And so in my experience with working with TEDxUCSD, I was able to help 6 renowned speakers perfect their talks. This ranged from speakers on campus to major speakers for corporations like Motorola and other things, like a lot of diverse speakers that I was able to really interact with. And I feel like this really worked to inspire me because I was kind of able to form a friendship and a bond with the speakers that I interacted with. And I was able to talk to them and actually learn what they were doing, as opposed to simply just listening to their talk. I was able to actually become friends with them, and I think it really helped me to become inspired and to actually learn and work from them. And so what I feel like helped me the most through my experience at TEDxUCSD was working with such a diverse group of undergraduates. Because I feel like as engineers, we tend to mainly stick with our clique of engineers, our group of engineers. And I feel like it really helps to gain some diversity, to go out and do other things, which kind of just open you up to, say, other majors and other people who work on different sorts of topics. So I also felt like we kind of formed like a good friend group through this, this like whole event and the organization of the event. And I always feel inspired to kind of learn more about what these other people are doing and kind of get a sense of what their lives are like. And I guess, like for instance, I've started reading more and learning more about other aspects of life than just engineering. And I feel like it always helps me to kind of realize why I'm studying engineering and why I want to contribute to the world. And so I feel like because we were like a good group of friends, basically, and because we interacted well with each other, we were able to create a much more successful event. And yeah, I really feel like being friends with the people you work with helps you to achieve better things and to see better results. So now I'll just kind of conclude with some life tips, or like my ultimate tips for success. So these are kind of more general things that I've kind of gathered from TED Talks, for instance, from other things, and just things that I would have liked to have known myself, say, going into my undergraduate career. So first tip is act confident. I'm not saying necessarily be confident, but if you act confident, then you will be more confident. So basically, the premise is maintain good posture. So I guess stick your chest out. Make yourself look confident. Yeah, that looks good. Nice. So making yourself look confident, I feel, really helps you to feel confident. And for instance, as you can see, the lady is slouched on the right, and you can tell like maybe she's not as interested in what she's working on, and she's probably not going to be as successful in whatever workplace or whatever she's actually working on. So I would say try to avoid doing stuff like making yourself look like you don't care, and instead make yourself look confident so that you feel confident and that you work better and you actually enjoy what you're doing. And also it's kind of bad for your back to slouch, so probably don't want to do that. And so yeah, I think you will look and feel more confident, and I feel like this has really worked for me. Not that I'm perfect at it, but I feel like it really helps to just kind of think to yourself, I want to look more confident, and just kind of put your shoulders back and puff your chest out. So that's the first tip. And then second tip, kind of obvious, I think it's really important to get enough sleep. And I feel like a lot of engineering students end up pulling all-nighters because they think it will help them to succeed in, say, finals or tests or whatever they're working on. And I feel like that's not really true. It's not really the case. Because even if you get a couple extra hours of studying, that doesn't mean that you'll have better memory storage or an ability to function that you can get through sleep. By sleeping, you can improve basically whatever you had been studying before. You can improve on your memory of that, whatever you had been studying, and you can also improve on your ability to function. I feel like that's much more key than just getting a couple extra hours of studying in. And realistically, the couple extra hours of studying is basically Facebook. Because, I mean, we all know that you're not actually going to be studying for the entire couple extra hours that you're spending staying up. And so, I give that a dislike. But basically, make sure you get enough sleep, and don't just kind of always flaunt that. Don't let the importance of sleep leave you, basically. So the third thing is a little less obvious, and something that I've kind of picked up on recently, is that stress can help you. And a lot of people immediately see that and are just like, yeah, like what are you talking about? But basically, sometimes you can tell when you're stressed out, your heart rate begins to increase and you become more tense. And you immediately think to yourself like, oh, this is terrible. Like you become nervous, you don't feel good, you feel like you're going to be hindered in whatever you're working on. And so you might feel like this. You might feel like you're just going crazy and there's just too much going on. And really, it's your body trying to help you succeed. And so this is something I've actually learned through TED Talks. And what I've learned is that your body is increasing your heart rate, is increasing how tense you are to kind of get you prepared for whatever is about to come at you. So it's like the moment before the race starts, you suddenly feel tense, you feel your heart rate increase. It's like a shot of adrenaline that's getting you to do better and to work harder. And if you think of stress this way, I think it can really help you to overcome stress in a way. So yeah, I think of stress as a good reaction rather than a bad reaction. So when you have finals week stress and you have too much stuff going on, if you think of it as your body trying to help you move forward, trying to help you study, I think it helps you a lot more than just thinking of it negatively. And so then you look like confident Fry instead of really worried and scared Fry. Okay, so yeah, I'd just like to thank my advisors, Dr. Foreman Williams and Dr. Albert Lin, for their excellent advice and excellent help throughout my whole undergraduate career. And I'd like to thank Tassine and the California Space Grant for giving me this opportunity and for yeah, just helping me out as well.